see the direction of velocity at any instant in a circular path. For example, a car is moving in a circular path in anti-clockwise direction. So we want to find the velocity at some instant, like at A point I want to check the velocity, at B, at C, at D. So now let's see how we will check the direction of velocity. So here if we will check at A point, so direction of velocity in the north direction. Now let's check the velocity, direction of velocity at B instant. So B instant we got the direction of velocity in the west. At C instant we got the direction in the south, and at the D instant we got the direction in the east. So what is the meaning of this? It means that in order to get the direction of velocity at any instant, we have to draw the tangent at that point. For example, if you want to check the velocity at this point, so let's draw the tangent at this point and you will get the velocity at that instant. So for a circular motion, to get the direction, you have to draw the tangent. So direction of motion is along the tangent drawn at that point of the circular path. Here note one thing, that at each and every point the direction is changing. Even though in a uniform circular motion, magnitude value is constant. For example, this car is moving with 10 km per hour speed. So this 10 km per hour is actually a magnitude. So magnitude wise this is constant. Magnitude wise this car is not changing their speed. But at each and every point direction of motion is keeps on changing. At 8 point north, at B point we got west, at C point south, and D point east. So here it is concluded that magnitude in a uniform circular motion is constant, but direction keeps on changing. Now let's see the difference between the uniform circular motion and uniform linear motion. So here we are a uniform circular motion and here we have a uniform linear motion. So one thing is clear, even if it is a uniform circular motion or uniform linear motion, speed is constant. So we will not talk about speed. Speed is clear that in both case speed is constant. Now let's talk about the velocity. So now let's understand what is a velocity. Velocity is a scalar quantity or vector quantity. So velocity we have a vector quantity. What is the meaning of vector? Vector means it is depending upon both magnitude as well as direction. So here in a uniform linear motion, magnitude is same and direction is also same. It is moving in same direction here. So magnitude is same, direction is same. But in uniform circular motion, magnitude same. Why? Because it is a uniform circular motion. But direction is not same. So here direction is not same. It means that as velocity is a vector quantity, magnitude same but direction is not same. So that's why velocity is changing in a circular motion. So velocity is a variable in a uniform circular motion, but in uniform linear motion velocity is constant. Okay, so this is the about the velocity. So now let's talk about the acceleration. If I'm talking about acceleration, what is acceleration? Acceleration is change in velocity. Acceleration formula is change in velocity over time. So whether a velocity is changing, in which case velocity is changing? In uniform circular motion velocity is changing. If in uniform circular motion velocity is changing, why velocity is changing? Because direction is changing. So velocity is changing because of direction, not because of the magnitude. So acceleration is produced in case of uniform circular motion, but in uniform linear motion acceleration is zero because velocity is not changing. So if you talk about the difference between the uniform circular motion and uniform linear motion, velocity is variable in uniform circular motion, but velocity is constant in uniform linear motion. Acceleration is not zero in uniform circular motion. Acceleration is zero in uniform linear motion. Clear?